So that is how the generators are represented. So next, we are going to see power transformers. Okay, as you well know, the power transformer is a very important equipment in our power system. So power transformers, both on the power line or the power circuit and in the instrument level, how are they represented in the electrical diagram? So as you can see, they are represented in various forms, okay? So these are some of the ways that they represent the power transformers. So if you see this kind of symbol in the electrical diagrams, you know clearly that what you are looking at is a power transformer, okay? We have some that are variable, which are the ones that you have arrow in the middle, lower left, okay? Then though they are auto transformers, then we have some that are adjustable coils. But in most one-line diagram, as we'll see later, or in most diagrams, you see them as two rings, okay? The lower left on the diagram, on the lower right on the diagram, lower in the left of your screen now. You see them as two rings overlapping each other. Okay, so when you see two rings overlapping each other like that, you know that that is what a transformer. Okay, so if you look at the middle of your screen, you will see that that symbol goes further to tell us something more about the transformer. Okay, if you look at it, you see the upper one, the upper ring having a Y, and then the lower ring having a delta. That tells us the kind of connections that we have in the transformer. That one end, the Y, is star connected, and the delta tells us that it is delta connected. Okay, so which means that on the Y side, we'll have 4 terminals as you have it on the physical structure of the transformer on your far right, upper right. Okay, you see the smaller bushings, there are 4 terminals there. Okay, that end is star connected. One of the terminal is the neutral terminal. We have line 1, line 2, line 3, and then the neutral terminal. Then the bigger bushing, which is the high voltage side, is the delta connected. Okay, so transformers like this could be represented by that symbology that we have in the middle. Okay, so most likely this is a step down transformer. Not most likely, it is a step down transformer. Okay, that takes the higher distribution voltage to the lower distribution voltage that could be used by household equipment. So on the lower part, you see some instrument transformers or power pack transformers. They are also represented as with those symbols that you see on the left part of your screen. So that is how they are represented also. So we want to look now on some instrument transformers. The first instrument transformer we are going to look at is the potential transformer. The potential transformer. When we say potential transformer, we mean voltage transformer. Okay, its duty is to transform voltage from one level to another. A higher. For the case of instrument transformer, is to transform a higher level voltage to a lower voltage, a lower level voltage for the purpose of monitoring and control or for protection. Okay, so that is the physical representation of potential transformers. And like we have it in our power transformers, they are also represented like that. We have them showing us the 2 windings that we have in the transformer primary and the secondary. In some cases, you may even have them as those rings that we earlier saw in the former example. Okay, so on the right, you have a circuit breaker. You can see the transformers, okay, the potential transformers. And this is a medium voltage circuit breaker that operates in the voltage range of between 1 kilovolts to about 66 kilovolts. Okay, so you see that those voltages, they are very high, or they are too high for us to actually play with, that is, in using them for controls. So we need a transformer to step that voltage down to control voltage, and that is exactly the work that the potential transformers do. Okay, so like you see in the lower middle diagram in your screen, it can be represented by two rings also. Okay, so the point of connection will help you differentiate whether it is a power transformer or an instrument transformer. Okay, so the power transformers, they are in line with your power source to your load, while the instrument transformers, they take from the line, okay, and branch to or take from the line to supply your control circuit. So if you see transformers like that, you will know that their function is to monitor what is on the line and then send the signal to other forms of control within the circuit. So that is what you have on the screen now. So if you look at that screen on your left, you'll see that the line voltage is about 5,500 volts, 5.5 kV. Okay, so the instrument transformer is attached to the line by H1 and H2. That is the high voltage terminal of the transformer. Then the low voltage terminal of the transformer will transform that high voltage to what? A 115 volts that could be read or used for control. But in this case, it is for monitoring purpose, for us to know what is happening in the main circuit. So what we have here is a step-down transformer looking at the main circuit. Then the output or the secondary of the potential transformer or the instrument transformer is supplying a voltmeter, okay, to give us an indication of what we have in the line. So your right of it shows how it is represented in the electrical diagram. It could be represented by what we have on the left, but the right in most cases shows how it is represented. So if you look at it, you see that it's branching off the main circuit. That tells you that it is an instrument transformer. So next, we are going to look at the current transformer. The current transformer also is an instrument transformer, but in this case, it's not looking at the main circuit or monitoring voltage as was in the first case. Its function is to look at the load that is in the circuit and gives us an idea of the amount of load in the form of current, okay, that is in the circuit. So now, if you look at the left, that is how current transformers are represented. That horizontal line is the main circuit line, okay, in the upper symbol. The lower symbol, that's the vertical line, okay. That is the main line, the power line, okay. Then the ring also around that line, okay, or the winding or coil around that line, that is the current transformer. It is the secondary of the current transformer, while the power line makes the primary of the current transformer. So the output from the secondary could be fed to an ammeter, as you can see in the diagram on your right. Okay. So if you look at this diagram on your lower right, you will see that we have, if you now trace the flow of energy from the circuit breaker, okay, on your left, once the circuit breaker is switched on, that will now take power from your source to your motor. But as it is going to the motor, you see that it will go through those rings. Those lines, they are they pass through the middle of the ring. Okay, so as you are loading the line, the current flowing through the line will what? Be increasing. Okay, and as the current is increasing, we all know that all current carrying conductors, they generate magnetic field. Okay, as those magnetic field are changing in direction because of the alternating voltage that is in the line, that will induce some voltage, okay, on those transformer, those rings, those current transformer rings that you see, because there are windings in those rings, okay, and the magnitude of what will be induced in them is dependent on the strength of the magnetic field, which in turn is dependent on the amount of current that is flowing through the line. Okay, so the output, which is usually voltage, is calibrated to give us a direct current, the current reading, the amount of load that we'll be having on the line. So you see, we have 3 current transformer and 3 meters, a combination of each, looking at each line, telling us the loading on each line. Okay, so that is how you see them in most of the electrical diagram that you come across. So next, we are going to look at the electric motors. How are they represented? You know, electric motors, they are very common electrical equipment in most electrical circuitry. You come across them. Okay, so how are they represented in your electrical circuits? So this is how they are represented. As you can see, a circle with an M, or with a M inside, and that M indicates that it's a motor. Remember the one that had G the other time shows that it is a generator. Then if you look at it properly, you see for the DC motor, polarity is indicated. Okay, we have the positive end and the negative end. Once you see it like that, you know that that motor that you are looking at is a DC motor, a direct current motor. Then the second one is an AC motor, because you see that sinusoidal wave sign, okay, under M. That is to tell you that there is an AC motor, okay, in that particular circuit. While some goes to the extent of showing you the different windings, okay, the 3 different sets of windings that we have inside the motor in the 3 phase, U, V, and W. Okay, we also have some representation, as you can see on the far right, is a DC motor. It is star connected. That is the Y you are seeing in the middle. Okay, so all of this goes to tell us clearly, show us clearly what we are looking at in our electrical circuit or our electrical diagram.